Right now, as you read this, the light hitting your eyes is already 8 minutes old, and if the sun vanished this second, you wouldn't know it until that timer ran out. Then, everything changes. Forever. Let's talk about what actually happens, second by second, day by day, year by year, if the sun disappeared right now. Not science fiction. Real physics. Real numbers. Real consequences for every living thing on this planet. First, you need to understand something most people get wrong. The sun isn't just a source of light. It's the invisible hand holding Earth in orbit. Our planet isn't floating in space by accident. It's locked in a constant tug-of-war between its own forward momentum and the sun's gravitational pull, which keeps pulling us back into a curved path around it. That pull travels through space at the same speed as light, 299,792 kilometers per second. So if the sun blinked out of existence, gravity's disappearance and light's disappearance would hit Earth at exactly the same moment, after an 8-minute and 20-second delay. For those first 8 minutes and 20 seconds, nothing would seem wrong. The sky would look completely normal. People would be going about their day with zero indication that the star at the center of our solar system was already gone. That's the terrifying part. You'd be living in a solar system with no sun and have absolutely no way of knowing it. Then the moment hits. Gravity releases first. In the same instant, the sky goes black. Earth, no longer held in a curved orbital path, would fly off in a straight line. A straight tangent line at roughly 107,000 kilometers per hour, the same speed we're currently moving around the sun. We wouldn't get sucked into some cosmic void or ripped apart. We'd simply become a rogue planet, drifting alone through interstellar space, forever. At the same instant, the sky would turn black in the daytime. No warning, no twilight, no gradual dimming. 1 second you're looking at a bright blue sky. The next you're staring directly into the void of space, stars visible in broad daylight for the first time in human history. Meteorologists and scientists everywhere would instantly know something catastrophic had happened. Now here's where most videos on this topic get it wrong. They tell you Earth would freeze instantly. That's false. Earth retains heat. The atmosphere, the oceans, and the ground itself act like a giant thermal battery. And that battery doesn't die in seconds. It drains gradually. Based on modeling by climate scientists, including research referenced by NASA and atmospheric physicists, the average surface temperature of Earth would drop below freezing within roughly 1 week. Within a single week, freezing. But here's the twist that separates fact from fiction. Even without the sun, Earth's core would keep generating heat. Radioactive decay deep inside our planet, the same process powering geothermal energy today, would continue for billions of years, regardless of whether the sun exists. This means Earth wouldn't become a solid frozen rock overnight. It would become something closer to a version of Jupiter's moon Europa, an icy crust, up to potentially several kilometers thick, sitting on top of oceans that stay liquid because of internal geothermal heat, protected from the vacuum of frozen space above. That single detail changes everything about the survival odds for life on Earth. Let's talk numbers, because this is where the scale of this disaster becomes almost impossible to comprehend. Within roughly 1 to 2 months, average global temperatures would plummet to around -73 degrees Celsius, according to modeling published in scientific analyses on rogue planet habitability. That's colder than the coldest temperature ever recorded on Earth's surface, which was -89.2 degrees Celsius at Vostok Station, Antarctica, in 1983. Within 1 year, estimates suggest surface temperatures could fall to around -100 degrees Celsius or lower. The oceans, which take much longer to freeze because water has an extraordinarily high heat capacity, would begin forming surface ice, but complete freezing of the entire ocean down to its depths would actually take somewhere between hundreds of thousands to potentially over 1 million years, according to thermal modeling of ocean heat retention on a sunless Earth. That's one of the most surprising facts in this entire scenario. Earth's oceans are so massive and store so much heat that liquid water could persist deep beneath the ice for an extraordinarily long time. Now let's talk about the economic and civilizational collapse, because this is where the trillion-dollar implication becomes brutally real. The global economy runs on one invisible input that almost nobody thinks about: solar-driven agriculture. Photosynthesis, the process every single food crop on Earth depends on, requires sunlight. Without the sun, photosynthesis stops within hours. Crops begin dying almost immediately. According to United Nations Food and Agriculture Organization data, global agriculture represents trillions of dollars in economic activity and feeds over 8 billion people. That entire system would collapse within days, not years. Food chains would begin failing from the bottom up. Plant life dies first, then herbivores, then the predators and humans who depend on them. Within a matter of weeks, humanity would face a global famine unlike anything in recorded history. And this is happening at the exact same time. Temperatures are crashing toward levels no human civilization has ever had to survive. Could humans survive at all? Scientists who've modeled sunless Earth and rogue planet scenarios point to a few narrow paths. Geothermal energy, heat from Earth's core, would become the single most valuable resource on the planet. Regions near volcanic activity or geothermal vents, similar to Iceland's existing geothermal power infrastructure, could theoretically sustain small underground or heated habitats. Nuclear power plants, which don't rely on the sun at all, would become critical infrastructure for the handful of communities that could maintain them. Deep-sea hydrothermal vent ecosystems, which already exist today completely independent of sunlight, organisms like tube worms and certain bacteria that derive energy from chemical processes rather than photosynthesis, would likely be among the only complex ecosystems on Earth to survive largely undisturbed. This actually connects to one of the most important scientific discoveries of the last 50 years. In 1977, scientists exploring the Galapagos Rift discovered entire ecosystems thriving near hydrothermal vents on the ocean floor, in complete darkness, powered not by sunlight, but by chemosynthesis, bacteria converting chemicals like hydrogen sulfide into energy. That discovery proved something profound. Life doesn't strictly need a sun to exist. It just needs an energy source and liquid water. Which is exactly why scientists searching for alien life now focus so heavily on icy moons like Europa and Enceladus, worlds with subsurface oceans heated from within, just like Earth would become without its sun. But let's be clear about the brutal reality for humanity specifically. Even with nuclear power, even with geothermal energy, even with the most advanced underground agricultural systems using artificial grow lights, the logistics of sustaining 8 billion people through a permanent ice age, with collapsing infrastructure, collapsing governments, and a collapsing food supply, would almost certainly result in a population crash of catastrophic proportions. Some scientific estimates suggest only isolated pockets of humanity, likely in the thousands or tens of thousands, could realistically survive long-term in self-sustaining underground or geothermally powered colonies. Meanwhile, Earth itself would continue drifting, alone, through the darkness of interstellar space, no longer orbiting anything, carried only by the momentum it had at the moment the sun disappeared. Over unimaginable timescales, spanning millions of years, our planet would eventually cool at its surface completely, its atmosphere potentially collapsing into liquid or solid form as temperatures approach the near absolute zero conditions of deep space. Though the ocean deep beneath the ice, kept warm by that same geothermal heat, could theoretically persist far longer than almost anyone assumes. Here's the part that should genuinely unsettle you. None of this is fictional exaggeration. Every piece of this comes from real orbital mechanics, real thermodynamics, and real astrobiology research into what scientists actually call rogue planets. Planets that drift through the galaxy with no star to orbit at all. And here's the wild part. Astronomers using data from missions like the Kepler Space Telescope and gravitational microlensing surveys estimate there could be billions of rogue planets in our galaxy alone. some of which may harbor exactly the kind of subsurface, geothermally heated oceans we just described for a sunless Earth. In other words, this isn't just a hypothetical. It might be the actual nature of countless worlds, already drifting through the Milky Way right now. Of course, none of this is something you need to actually worry about. The sun isn't going anywhere for a very, very long time. Stars like ours don't simply vanish. They undergo a slow, multi-billion-year transformation, and current astrophysical models suggest the sun has roughly 5 billion more years of stable hydrogen fusion ahead of it before it eventually expands into a red giant. What this thought experiment really does is something more valuable than fear. It reveals just how fragile, interconnected, and precisely balanced our entire existence really is. Every heartbeat, every meal, every breath of oxygen produced by plants, every ocean current, every season, all of it traces back to one star, 150 million kilometers away, quietly holding the entire system together. So here's the question I want you to actually sit with. If you had just 8 minutes and 20 seconds of warning before the sun disappeared forever, what is the one thing you would do first? Drop your answer below. I want to see what humanity would actually choose in those final minutes of light. If this kind of deep space, mind-bending science content fascinates you, make sure you follow this page. This is exactly the kind of content we break down every single week.